Hello, fellow econometricians. My name is Nicholas, and I will have this small YouTube lecture in Python for econometrics. Was at least the plan. We're gonna start off with the first video where I'm just gonna introduce Python and what it's about and its advantages and so on, and then in the second video I will go on and do some more functional stuff with the econometrics. But we're just gonna start today with introducing Python. I'm not gonna go that super deep into specifical details, which might be useful if you want to take this programming stuff seriously. So my recommendation is for you to go onto this site, Learn Python the Hard Way /book, and just go through these steps. It's a really good guide. I used it myself when I learned Python a while back ago, and yeah, it's just a really good walkthrough. Uh, and yeah, so what is Python? Python is a high-level multi-paradigm programming language, and that means that it's both support object orientation and structured programming and so on. This of course means that you can do everything you want with it basically. However, it is designed to be like focused on the speed of development. The focus in the writing is the speed of writing. You're supposed to have a really smooth and fast way of writing code, which is of course really useful when you want to model stuff and you're not really in the need to have some extremely complex yada yada for for stuff. You just need to pump out some kick-ass algorithms or anything, something like that. However, you can do pretty serious stuff with it. Yeah, you can just like Google programs made by Python and list of Python software. Yeah, and you can just see here how we have some different kind of like BitTorrent, Blender, Bazaar, Anki, Dropbox. Yeah, you probably recognize a few. Yeah, Civ 4, big fan of that. And yeah, you can just see that it's a pretty strong like program language because you can do a ton of stuff in it. And that is kind of why it's better than, in my opinion, better than MATLAB and R, because it does the same kind of, it has the same kind of abilities to do the computational stuff as MATLAB and R, but it has that extra that if you want to build some kick-ass structure, it is much better than MATLAB and R. And you can also handle data much better and easier than in the corresponding, and of course faster. That is also one of the main points. Like if you want to say you want to handle 3 million rows of data for some experiment or some such, Python will handle that much more faster than for example with the MATLAB. So yeah, that is a big thing. Yeah, and we can start off by just showing you the first stuff. So the setup. If you have a Mac, as I do, the Python compiler is already installed in your computer. So you can just if you open up your terminal, you can just, if you press Command and Spacebar, you will get the Spotlight search, and then you can just write terminal, and wow, there it is. And you start Python by just writing Python basically, and you start Python, and now you can do like 1 + 5, oh yeah, and Python will do that calculation for you. You quit this part by just writing quit, and yeah, that's it. An important thing to show you is how you can use the terminal in itself with uh, when you execute Python programs, and yeah, basically every program, if you're writing programs, you sometimes need to use the terminal. So I'll just introduce you also to some very simple terminal commands. Yeah, and if you are on a Windows computer, you can go to this site and just go through this guy's guide instead. He because I don't really know how. I don't use Windows anymore. I'm over that. So yeah, and if you have Linux, it's fairly similar to how you operate it and in a Mac. This guy recommends Text Wrangler, but I myself prefers the subliminal text 2. Subliminal text 2. And yeah, it's free, open source, it's really stable, and it has some really cool features such as text completion. You have an overview right here. There's a lot of stuff that is just sweet with it. For a basic text compiler, that is my uh, that is my weapon of choice. I will show you Enthought Canopy later on for actually doing the research parts. But I will start with subliminal text just to show you the basic programming stuff. All right, so let's start with the most basic example that all new programs has to go through, and that is to write hello world. Now I will also show you a small comparison to how Python looks in comparison to, say, for example, C++. To write hello world in a Python program, you only print hello world, and that is absolutely just it. However, now we need to save this in a folder and we have to run it from somewhere. I have prepared some, but I will show you just how to do this in the terminal if you were, say, example, do it from the start. So we're gonna press ls, which just lists. And now I got the list of all the stuff that I have in my Niklas Lindeke folder. And now I see I've already created this folder for the example. So new Python, we do cd, which stands for change directory, and put a new Python. And now we're in that, and we push ls, and there's nothing in it. We could do this even, mkdir, which stands for make directory. So we're in a new directory, and we want to make another directory in that. We're gonna push test, and we can press ls, and we see that test is now in it. So we could change directory to test. Oh my god, we're in test now. Nothing is in it though. So yeah, we could move back by just pressing cd again with nothing, and we'll back into Niklas Lindeke. We're right there. New Python, and we're in the right one again. Right, so we're gonna save this one down to the new Python hello world. We'll name it hello world .py, which is the file ending for all Python files. Save, and you can now see that it is syntax highlighted. However, we will try to print this now, or we're gonna start our program. We got 3 rows too much. That is just me. I want my rows to be even. All right, so we're gonna just start Python. This is how you start a program within the terminal. You first write Python to activate Python, and you open Python with, you're gonna compile a program with the Python compiler. So you write Python, then hello world.py, and it just prints hello world. Alright, so I'm gonna go through data types now. A data type is the different types of data the data can have. You can have it as strings, and you can have it as floats, and you can have it as booleans. I'm going to start with a string. For example, this right here, it's a string. It's basically just a variable which will have some string value. It's really hard for me to explain, but it can be a hello, it can be a number, it can be a lot of stuff actually. But that's kind of the point with it, it can be anything. But that is also the drawback. Like if I would have a string that would be 1.5, I would not be able to compute it with anything because the computer will interpret it as a string. So to have a number as a string is stupid because it is useless. However, if you want to like print out something, as we are doing here, a string is very good to have. An integer is a number without the decimals. I can show you like right here. X is equal to hello world, and yeah, this is how you comment in Python. You just write a hashtag or a sharp sign, depending on what kind of generation you belong to. I am a string, and we can do y 2. I am a integer, z 2.9. I am a floating point, and the k is equal to true. I am a boolean. Alright, so these are my 4 main types of data. We have the string, which can be hello world, how are you? It can just be anything. Question marks, and but you can't have these Swedish signs, but yeah, whatever. But yeah, it's just words basically. But you can also like that, but it won't be able to interpret that too as a number. For that, you will have to go to the integer, which is a number with no without a decimal point, and this is useful for the when you're gonna do like large if you have large numbers and you don't need a decimal points. The integer doesn't take as much space as a floating point, so it's calculated much faster. And if you just have to count through something, for example, if you have to do a loop, it is good to define that as an integer, so it will just compute that faster. And if you want to do really large numbers, you can do L is equal to a lot of zeros. I am a long. And this is also kind of the thing with Python, is that you don't have to define all the variables all the time. It will realize what it is by itself most often. Sometimes, however, you will have to convert the variables, but that is quite natural. It's nothing weird about that. You will realize when that's needed. Right, so the floating point is a number with a decimal, and yeah, it can just have like that is basically just because you might need a lot of information in the decimal points. It's a bit more heavier on the processor and the memory than the integer and the long, but however, sometimes you just need a lot of information from that figure or variable. And our last one, k is equal to true, is a boolean. So the k is the boolean variable, which can take the state of either being true or false. And this is useful in programming because sometimes you just need to have a switch which says now this is true, and if this happens it will not be true anymore. And yeah, that is very useful in a whole lot of senses. And moving on. We'll go through a statement, the most important statement of them all. It will probably be the if statement. And written in Python, the if statement is fairly simple. Like we'll say x is equal to 2, and we have like if x is less than, more than 2, then, like, that is the thing. You'll have to imagine this sentence in your head when you're gonna do this. Like, if something something is something something, then boom, you do stuff. You print. Cool, because that was just so cool what we did right there. And yeah, let's check that out. Python hello world.py. All right, so in this example we saw that x is equal to 2. However, our statement said if x is more than 2, we'll print 2. But now it is equal. So we can do this and print it again. Oh, it was cool now, because now it's both more than or equal. We can do this, and it is still cool because it's 4, which is more than 2. And that is basically how you do it. This is kind of the why if statements have a Boolean perspective in them, because you always do the if something is equal, more than, or less than, or not equal to. You can go through all the different ones in here when you get to the just variables, printing, strings, text, somewhere, Boolean practice, memorizing logic. That is basically, in 27, 28 you will learn a lot more about the Boolean logic. But for a quick run through, you have the equal as being the double equal to, because the single equal is basically more of a definition type of thing, because you have the x is 4, and when you have to do the equality sign, you have to just do the double equality. If you want to say that it's not equal, you press exclamation point and then equal. And and as you saw before, more than equal to and less than equal to. We can save this there, and we can see it's not cool anymore. And now we can try out another thing, which is called to have a second statement, like in the if. Like we have a situation where we want to see, okay, if this is not equal to 2, it is cool. Or if it's not, or if else if, like, which this stands for, elif, else if, else if x is more than 3, we can print way cooler. We'll see. Oh, it was way cooler this time because x is actually equal to 4. And so that is the basics of an if statement. I'm gonna go through the smaller example later about how to do a little bit an extended version of the hello world. But please feel free to pause anything, or you're just watching a video right now, so you can basically just do anything you want. This is the basics. I'll be right back in the next